Hello class, welcome to another lesson. Today we're going to be learning about negative exponents and having an exponent of 0. Our learning goals are I can understand and apply 0 exponents, and I can understand and apply negative exponents and use properties of exponents to simplify expressions. So let's get started. Going back to the first page of your packet. So we've been telling you guys that x to the 4th power means x times x times x times x. 4 being the number of times x is multiplied by itself. That is a partial truth. Okay. The real truth is that it's actually 1 times x times x times x times x. Okay. We haven't told you that before because the 1 doesn't really matter, because if you multiply anything by 1, you just get itself. Okay. But that does matter when it comes to x to the 0 power. As you guys can see, x to the 3rd is 1 times x times x times x. X squared is 1 times x times x. X to the 1st is 1x, and x to the 0 is simply just 1. Okay, so that is why x to the 0 is 1. That is also why x to the negative 1 power is 1 divided by x. So instead of multiplying, when we get a negative exponent, we're dividing by x. Okay. So that's why x to the negative 1 is 1 divided by x. So we take the 1, and now we're dividing by x. X to the negative 2 is 1 divided by x, which is the same thing as 1 over x squared. X to the 3rd power, or negative 3rd power, is 1 divided by x divided by x divided by x, or 1 over x cubed. Okay. All of those are the same thing. Notice how x to the negative 1 power is simply 1 over x to the 1st power. X to the negative 2nd power is 1 over x to the 2nd power. You're simply flipping it to the denominator. So let's take a look at our notes. All right. We're going to be talking about the quotient property. Okay. So if you remember, the quotient property states that if you have the same base and one is at the top and one is on the bottom, okay, you simply subtract the exponents and then put that on the numerator. Okay. So we have 3 to the 5 minus 2, which is 3 to the 3rd. Expanded form is 5 3's. Expanded form is 2 3's. You cancel, you get to 27, or 3 to the 3rd. Okay. Same thing down here. This time it's 3 3's in the bottom, so we have 3 3's in the bottom. We cancel 3 3's, we get 3 squared, which is 9. Notice how we're going up by 1 each time. Okay. Inside the denominator, one more 3 down here, so there's 4 3's, cancel 4 of them, we're down to 3. Finally, we're down here, we have 3 to the 0 now. Okay. We're canceling all the 3's, which leaves us a remainder. What we have is 1 at the very end. We're dividing by 3 each time. So please be sure to include this inside your notes, including this pattern right here, divide by 3 every single time. We're adding another 3 to the denominator, we're dividing by 3. Okay. Which is why we're going down by powers of 3. Okay. So, again, this time we're dealing with 5. 5 to the 3rd divided by 5 to the 3rd. Using our quotient property is 5 to the 3rd minus 3rd, which is 5 to the 0. We're canceling them out. We have 1 at the very end. Okay. Flip those 2 points right there, so y to the 0 is over here. Again, subtracting the exponents gives us 0 in the exponent, which is 1. Okay. Same thing down here. So anything that is raised to the 0 power is always 1. And we've talked about that before as well. So, a to the 0 power is 1. Any number to the 0 power except for 0, okay, that's what this says right here, except for 0. A is 0, if your base is 0, 0 to the 0 power just doesn't exist. Okay. 5 to the 0 is 1. Anything besides 0 to the 0 is going to be 1. Negative exponents. Okay. We haven't talked about this yet, but they do exist, and they are easily changed into positive exponents, which we're more familiar with, and we're going to talk about that. Okay. So here we have 3 to the 4th and divided by 3 to the 3rd. Using our quotient property, we get 3 to the 1, and we cancel out 3 3's. You get 3 at the end. Here, we're going to have our 0 property. Right here is 3 to the 4th minus 4 because we have 3 to the 4th and 3 to the 4th together. 3 to the 0 cancels out. We get 1. And we also know that the same thing divided by the same thing is also 1. Here we have a bigger exponent inside the denominator. Using our same quotient property, we get 3 to the 4 minus 5, which is 3 to the negative 1. Well, if we expand it out, we get 4 3's on the top, 5 3's on the bottom. When we cancel, we have 1 3 left in the bottom. So therefore, 3 to the negative 1 is 1/3. Try another one. Here again, we have a bigger exponent inside the denominator. That means we're going to have 2 leftover 3's in the denominator, which is 3 squared, which is 1/9. Okay. If we were to do this with the 4's, it would look similar like this. Okay. Again, here we have a higher exponent inside the numerator, so we're just going to have 3 minus 2, which is 4 to the 1, which is just 4. 4 to the third, 4 to the third. We know that's going to end up being 1 as well. Here we have a bigger exponent inside the denominator, 4 to the negative 1, because we're doing 3 minus 1. We're keeping this in the numerator, by the way. Okay, but that's going to be the same thing as 1/4, or excuse me, 1/4, which is 1 to 4 to the 1, 1 over 4 to the 1, which is 1/4. Here again, bigger denominator exponent. 4 to the negative 2nd because of 3 minus 5. And that's our quotient property again, which is actually just 1 over 4 squared. We're just bringing that down to the numerator because we're going to have 2 4's left over in the denominator, which is 1/16. Similar thing goes on here. Okay. We'll have 3 4's left over in the denominator, so the denominator is going to be 1 over 4 to the 3rd, which is 1/64 when evaluated. So, we notice that the base, when we have a negative exponent, simply gets reciprocated down to the bottom. Okay? And becomes a positive exponent. Once we take it from the numerator to the denominator, it becomes a positive exponent. Okay? So therefore, a to the n, negative n, where n is a number greater than 0, okay? So the negative n being that it is now negative, 2 to the negative 1 is 1/2 because it's 1 over 2 to the first power. Here, this is negative 2, we take it down, 1 over 5 squared because it is taking it to the denominator, reciprocating, and making it positive. Please note that when you do this, the m to the 2nd power, okay, if we have 3m to the negative 2nd power, again, that negative 2 only applies to the m. We do not bring down the number with it that's next to it. Only bring down that variable or the thing that is right next to the exponent. Okay, because that exponent, again, only applies to that number. However, if we have 3m in parentheses to the negative 2nd power, now that negative 2nd power applies to 3m, both of those things, so you bring both of those things to the denominator. Okay, so that would be 3m to the negative 2 is 1 over 3m squared, and then we can use our power over product property to make this 9, 1 over 9m squared. And that would be what it would be simplified. Okay? So let's take a look at some of these. This is a story that might help you to remember things. Okay. The easiest way to deal with a negative exponent is to remember the story I told you in class, tell you in class later, about being in the man cave. So if you know what, we're not going to deal with that one right now. I'll tell you guys in class. So here we have 2 to the negative 3rd, which means that it is 1 over 2 to the 3rd, making it positive by bringing it down to the bottom, or 1/8. Negative 10 to the 0, anything that is to the 0 power is 1. Here, we're going to apply our power of a quotient property, making 1/4 to the negative 3rd. We're going to apply the negative 3rd to both the numerator and the denominator numbers, so we have a 1 to the negative 3rd. That means that this comes down, and then this comes up. And we'll talk about why that comes up right now. So, 1 to the negative 3rd okay, is 1 over 1 to the third, okay, over 1 over 4 to the third. So this is 1 to the third, which is, we know that is 1. Okay, so that is 1 divided by 1 to the third, which is 1, and 4 to the third, we know is 64. And we know that dividing by a fraction gets us, we have to put that over 1. So this is going to be 1 over 1 times 64 over 1, which is 64. 64 again is 4 to the third. So therefore, all we did was bring this 4 to the third, 4 to the negative third, okay, up to the numerator. So when we have a negative exponent in the denominator, we just bring that up to the numerator and make it positive. Okay. Again, anything to the 0 power is 1. We're bringing this down, making the answer positive, or excuse me, the exponent positive. So we have 1, 7 to the third, which is 1, I don't know why this is so simplified, 1 over 343. Here again, we're only taking the z to the denominator because this negative 2 only applies to the z, not to the 2. Similarly over here, this negative 4 exponent only applies to the x, which is why we're bringing it down. Does not apply to 3, does not apply to the y. Okay. Try these on your own. Hit pause on the video and try these on your own, and we'll go over it. Here we have 3 to the negative 4th times 3 to the 7th. We can do this multiple ways. We can bring this down to the bottom, making it 13 over 7 over 13 over 4, making this into 13 over to the third power using our quotient of powers property. Okay, powers of quotient property. Excuse me. We can also just simply add these two numbers together, okay, using our power over product property, and we would get also 13 to the third. Here, we can use our quotient property. That would be x negative 7 minus 4, which gets us x to the negative 11, which we know is 1 over x to the 11th. Notice how I'm always changing the negative exponent into a positive exponent whenever I can, because it's only simplified if we have positive exponents. Similarly over here, this is the simplifying the numbers first, which is 3 in the numerator. If we want to do this, we take this m to the negative 2, bring that up, combine it with this m, gets us 3m to the third. You can also think about it in terms of the quotient property. 1 minus negative 2 is 3 to the third. Same base over here. So we can do negative 7 minus negative 4 using our quotient property, which gets us 2.5 to the negative 3. Bring that down to the denominator. And we can simplify that by doing 2.5 to the third power, and so forth. Okay. Similar thing over here. We get a negative exponent in the numerator because 3 minus 4 is negative 1. We put that always, when we're using the quotient property, always putting it inside the numerator. But then we bring it down to the denominator to get rid of the negative exponent. Okay. Over here, 14a to the negative 5 divided by this. We combine these first, a to the 1, a to the negative 4, we get a to the negative 3. Flip-flop these, so we get 14a to the third, and this is 14 coming from up here, it's 14 because we do not bring this 14 down, we do not bring this 14 up, we leave them the same, they just happen to be both 14. 14a to the fifth, that means we are going to use our quotient property, or we can cancel them out. We know that there's 3 up here, 5 down here, that means we're going to cancel 3 of them, and that just leave us with 2 in the denominator, a squared, 1, we know 14 divided by 14 is 1, so we get rid of those, they cancel each other out. Alright, try the last page on your own. I will post the answers in the work up here. Our goal is to write these without a fraction bar, which means we do have to use negative exponents. This is not simplifying them, this is just showing how they can be represented without a fraction. So we have 1 over 15. 15, bring that up. We'll put a negative on it because we're changing it from the denominator to the numerator. Same thing over here, a to the third, positive, and already without inside the numerator, we need to bring this up in the numerator so we don't have a fraction. C to the negative fifth, 18 to the negative 1, 100 to the negative 1, 3c negative 2. At this time, you are done. Be sure to have all your notes written out. But I also want to point out this fun joke at the bottom of your front page. In your own words, please explain why this joke makes sense.